Chapter 4, Section 28, Correcting Data Inconsistencies. In the previous sections, we have seen how to detect data inconsistencies. Having identified inconsistencies in your dataset, the next step is to correct them. This ensures uniformity and enhances the reliability of your data for analysis. In this section, we will explore three key approaches: standardizing formats, normalizing values, and reconciliation. First, let's see what is format standardization. Format standardization involves aligning textual and numerical data to consistent rules and representations. This is essential for avoiding errors in processing and analysis. A common example is standardizing date formats, which often appear inconsistently across datasets. Let's see how to solve the problem of inconsistent data formats by Python. Here, we use Python pandas library to standardize the date formats. First, let me import pandas and create a sample data frame. This data frame contains two variables, transaction ID and date. Date column contains dates in three different formats. This illustrates a common real-world problem where dates are stored in mixed formats. Let's define a list named formats. It is a list of date formats. These formats will be used to parse the dates correctly. The parseDate function is defined to handle the conversion of dates. This function ensures that dates in different formats are parsed correctly. This function takes a date as input. Using for loop, it loops through each format in the format list. Inside the for loop, it tries to parse the date using Ph.D. to datetime with the current format. If parsing fails, the loop continues to the next format. If no formats match, the function returns Ph.D. NAT, not a time, indicating a missing or invalid. Then apply the function. The apply method is used to apply the parseDate function to each value in the date column. The apply method is needed because the parseDate function is designed to process one date at a time, not a whole column of dates. Each date is checked against the defined formats and converted into a standardized datetime64 object if successfully parsed. If no format matches, the corresponding entry will be NAT. Now, the data type of date column is converted to datetime, and the format is standardized. So, we can use datetime method to convert the dates to another uniform format in this way. Let's move on to value normalization. Value normalization involves converting numerical data to a common scale or unit. For example, if weights are recorded in kilograms, grams, and pounds, they must be normalized to a single unit for meaningful comparisons. Let's see an example of how to normalize weight data into kilograms by Python. Here, we use a sample data that contains three variables, item ID, weight, and unit. We can see that the data points are recorded with different units. Here, we want to normalize it into kilogram. Next, define a dictionary named conversion factors. This dictionary maps each unit to its equivalent value in kilograms. Kilograms remain the same, and grams and pounds are converted to kilograms using this ratio. Next, add a new column, weight kg, to the data frame to store the weights converted to kilograms. Then, use apply method with a lambda function. In this function, for each row x, the weight x weight is multiplied by the appropriate conversion factor based on the unit x unit. The last argument, x equals 1, ensures that the function operates row by row. Print the data again, and we can find that the weight underscore kg column contains normalized weight data. Let's go on to another method to handle inconsistencies, reconciliation. Reconciliation resolves the conflicts between entries by unifying categories or merging similar items. For example, product names like widget large A, widget small a, and widget -a may need to be merged into a single category. This is done based on similarity. Let's see how to implement reconciliation by Python. First, import the process from Fuzzy Wuzzy and Pandas. Then, create a simple dataset. It consists of only one variable, product, which consists of 5 unique categories, but 3 of which seem to be the same, widget A. Next, let's define a function that reconciles categories. Here, let's name the function reconcile categories. This function reconciles similar categories in a specified column of the data frame. So, the first and the second argument are the data frame and the column, respectively. The third argument is threshold, which is a numeric value between 0 and 100. This argument sets the minimum similarity score for matching strings, and its default is 90. In the second line, this function extracts unique product names from the column and stores them in a list named unique values. The third line creates an empty dictionary named reconciled to store mappings of each value to its closest match. Next, create a for loop to iterate over unique values. For each value in unique values, Fuzzy Wuzzy's extra1 method is used to find the best match among all unique values. The argument score cutoff is set to threshold in order to ensure only matches with a similarity score greater than or equal to the threshold are considered. The next if sentence updates the mapping dictionary. If a match is found, it updates the reconciled dictionary with the original value and its closest match. Next, add a new column, product underscore reconcile, to the data frame. This column contains the reconciled values based on the mapping dictionary. The map method is used to transform or map the values of a Pandas series based on a given mapping dictionary, function, or another series. Here, the map function applies this reconciled dictionary to each value in the data column series. It replaces each value with a corresponding value in the reconciled dictionary. Here, let's use f method to dynamically change the new column name so that it reflects the target of the reconciliation. By doing so, if we reconcile the product column, the new column name will be product underscore reconciled. If we reconcile another column, this function adds a new column with a name reflecting another column's name. Finally, return the updated data frame. Next, apply the function to the product column of the dataset. Then, print the updated data frame to show the original product names alongside their reconciled version in the new column. You may wonder that why similar categories were merged into widget large A instead of widget small a or widget -a. The reason lies in how the Fuzzy Wuzzy library, specifically the process extract1 function works. Here's a detailed explanation. The reconciliation process starts by iterating through the list of unique values. Here, the order of unique values is determined by how the unique values appear in the dataset. In this case, widget large A appears first in the product column, followed by widget small a, widget -a, etc. This order affects the reconciliation process because the matching is always performed against all the values in unique underscore values. The process extract1 function compares a given value with all values in unique underscore values and identifies the closest match based on the similarity score. If multiple matches have the same highest score, Fuzzy Wuzzy typically selects the first occurrence in the unique underscore values list. For example, when processing widget small a, process extract1 finds that its closest match is widget large A because widget large A appears first in unique underscore values. The similarity score between widget large A and widget small a is sufficiently high, for example, above the threshold of 90. Thus, the mapping dictionary reconciled maps all the similar values into widget large A. So, why not merge to another similar value? The first reason is case sensitivity and similarity scores. The matching process uses the Levenshtein distance, which considers character differences and case sensitivity. Widget large A has a slightly higher score compared to widget small a. The second reason is that there is no explicit target for merging. The reconciliation function does not explicitly assign a target value for similar categories. Instead, the value that gets matched first in the unique values list becomes the target. When process extract1 identifies a match, the first occurrence in unique values with the highest similarity score becomes the de facto winner. Since widget large A appears first in the unique underscore values list, it naturally becomes the default value to which other similar entries are merged. If you want to control which value similar entries are merged into, you can modify the reconciliation process. First, sort unique underscore values based on a specific rule such as alphabetical order or frequency in the dataset before starting the matching process. Then, define preferred target value. Explicitly set a preferred target for merging. In this example, we calculate the most frequent value and use it as the default. Using these snippets, we can revise our original function in this way. We can custom matching logic here. Instead of matching each value to its closest match in unique underscore values, all values are mapped to the predefined target underscore value, ensuring consistency. Thank you for watching. Please thumbs up and subscribe to my channel.